Hello and welcome to Building Context. This is a series of Tech Talk videos that we're doing on APIs and API-based applications and API security. My name is Chris Westfall. I head up product marketing here at Salt Security. And again, today I'm joined by Michael Otsbitsky. He's our technical evangelist. Welcome, Michael.
Hello, Chris. Good to be here again.
I'm glad to have you back. I'm excited to talk about this topic that we have in front of us. I'm just going to come out and say it. I'm going to say that, a lot of organizations are just spinning their wheels when it comes to API security. They're doing a lot of stuff. They've got a lot of tools in place, and we're still seeing breaches. So, I mean, what do you think?
Yeah, it's very true, right? And it's many times I would advise organizations. It's a tough thing to kind of break the news to them, right? Like we've talked about this before, right? APIs have been here for decades. We probably thought it was a pretty solved problem. Maybe it was with traditional perimeter thinking and perimeter controls. A lot of times what I would see, when it came to API security, was that, TLS, right, encrypting, protected transport was one of the tools of the trade. The other was identity and access management. IAM, enforcing authentication and authorization. So you get into things like OAuth and OpenID Connect, like those newer protocols for authentication and authorization. These are components of API security, right? The problem is, we talked about this in the last session, was that the range of attacks against APIs are much broader. Protected transport is really not going to buy you much, other than if somebody's going to try to intercept your traffic in transit. And we talked about how attackers will reverse engineer client-side code and they can intercept their own machine communication. So it's really not buying you much, except, preventing certain types of network-based attacks like man in the middle or compromising routers or rogue Wi-Fi hotspots. So it's very important to kind of consider, which level of the stack am I kind of protecting within. It was just, go ahead, Chris.
An example, to kind of dig deep on or a little bit deeper on your encryption example, instead of an attacker, instead of doing a man in the middle attack to, gain access to another user's data, they're going to look at ways to manipulate the API in order to access access a user account or user data via the API, as opposed to, in the middle of the transport. So
right, yeah, compromise somebody's authenticated session or obtain their credentials, right? And then I'm authorized to see it, so it doesn't matter, right? Like you can encrypt data till you're blue in the face, but at some point the system is going to decrypt it, particularly if you're authorized,
right?
And you're going to see it, right? And there's other ways that attackers will target encryption, like harvesting, encryption keys, particularly if you've kind of bury them in client-side code, and please don't do that, right? Like we talked about how client-side code is basically ripe for the plunder. People can reverse engineer that code very readily. But yeah, encryption, it solves some very specific needs, right? Some compliance and regulation mandates that you need to encrypt. We should do it. And you have to kind of think about, am I encrypting data in transit? Am I encrypting it at rest? And am I encrypting it in use? TLS is really just, it's encrypting, data in transit. But, at the ends of that communication, the data is going to be unencrypted. And as you said, if I'm an authorized user, I'm always going to be able to see that data. So there's limitations to what encryption really buys you. And it really doesn't solve certain things like privacy impacts, for instance, right? That's more so an issue of what's the data am I collecting and exposing? How are APIs serving that up? There's much wider set of problems you need to address beyond just, is this data readable if it's, somebody tries to access it at rest.
Yeah. So so we talked about encryption. You're still going to do it. You still need to encrypt data in transit. You still need to encrypt data at rest, but it's not enough. You start talking about authentication and authorization.
Yep.
Again, these are kind of core principles, right? You're not going to leave your doors and windows wide open. You're going to make sure that that's all buttoned up. But, why is that not enough?
And it's there's kind of I'm sure you've heard of this, Chris. It's kind of prominent in the industry now, particularly as organizations move towards cloud. But you've heard a lot of like the perimeter is eroded, right? It's kind of beating a dead horse. We've heard that, if you were in the world of data center computing, it was a pretty well-defined network path. You could control things at your network egress or ingress. firewall that connection, right? Shifting towards cloud kind of throws a wrench in the works. Like your data and your systems can exist in multiple spots. So what is your entry point? So that traditional network perimeter is kind of gone, right? It's very hard to enforce that. You could argue it kind of reemerges with zero trust, which maybe we'll get to in another session. But with that, knowing that network perimeter is really hard to control now, there's kind of a shift towards authentication and authorization, right? And then identity becomes the new perimeter. So absolutely critical. Identity and access management is the backbone of many things in security, certainly API security. But it's not the end all be all, and there's reasons for that. One of them is that it's very hard for an organization to know all of the APIs they have, right? We kind of talked about the explosion in the number of APIs you might have in your organization or that you're interacting with externally. Traditional means of inventorying all that, they didn't work, right? So you kind of run into this need for continuous discovery. And there's a lot of incidents where API endpoints or maybe functions within those endpoints are not authenticated or authorized, right? And this is why we see those types of issues in the OWASP API security top 10. And it's, sometimes it's a very simple mistake, like somebody forgot to put authentication on an endpoint, or maybe they used a weak form of authentication, like API keys only or basic authentication, as opposed to something like OAuth or certificate-based authentication, more robust forms of auth. On the other end of the spectrum is it gets very complex, right? OAuth can be very difficult to implement properly, particularly when you start thinking about your entire partner ecosystem, right? How do you enforce auth and connect with different identity stores and delegate access? It's very common for organizations to make mistakes implementing OAuth, or enabling things like second factor authentication. Those systems are even prone to attacks themselves, like such as brute forcing. We've seen that recently with Microsoft authentication. The other reality is, attackers, even in that most robust, authenticated and authorized environment, the attackers know that they can always target the endpoint, right? Like harvest somebody's authenticated session. And how am I going to get that? Maybe I just ask them, right? Like that's the phishing attack, like kind of, it's that simple, right? Or I'm going to compromise their endpoint, right? And an endpoint, think about all the ways you use computing services today. You're using your desktop, you're using your smartphone, maybe you have a tablet. You probably have smart devices, right? All of those things, they need to authenticate and authorize. You're plugging in credentials. Do we know that all of them are secure? I personally, I don't. If I probe deeply enough, I'd probably find some weak code that I could harvest credentials as an attacker, and then I have authenticated context, right? And it's there's kind of in the security world, there's always the balance of usability versus security, and this comes up really frequently as you talk about mobile device computing and connected homes, right? You want devices and services that are easy to use, right? So you're going to kind of sacrifice some of the let's say challenges, right, that you would give towards a user, right? You have to kind of trust that endpoint a little bit more explicitly. You might have very long living sessions. Unfortunately, that kind of increases the attack window, right? So attackers will go after mobile endpoints and connected devices and harvest those authenticated credentials, and then they might use that in a web channel, right? Because maybe you're restricting functionality in kind of those IoT scenarios or the mobile scenario, but in web you have full functionality. But you might allow any authenticated session to work in any of those channels, right? So attackers will do that. They'll pivot between different channels to find the exploitable endpoints and functions. So that's why we kind of say that identity and access management, yes, do it, but there's a lot more to it, right? Attackers they'll harvest authenticated sessions and they'll target access control mechanisms.
So another area where arguably we're kind of spinning our wheels is around rate limiting. And I know we touched on this a little bit in a previous video, so we won't go into detail, but
Yep.
rate limiting is another one where it's difficult to get right. It's difficult I guess, plan for things like seasonal spikes or
Yep.
changes in applications. It's something that you need to have. It's sort of a loose control that it's very difficult to tune in such a way that it's going to capture all the corner cases.
Yep. Yeah, and I
Um,
mean, there's only so many things you could do in code, right? So how do you plan for that ahead of time? You can't, right? Rate limits they occur in infrastructure, right?
yeah.
Maybe it's server level. It's probably some network-based device that's doing rate limiting. The other piece we kind of touched on is the large variety of API consumers. That's a really changing or shifting IP address space, right? You don't know, particularly if you're doing cloud computing and hosting services in cloud.
Mhm.
You might be rotating IP addresses yourself, right? You're in Amazon's IP address space, but you're spinning up things dynamically, containers and VMs. It's very ephemeral, right? So rate limits unfortunately need those things. That's how they're informed. Like I need to
Right.
know who is the requesting IP address, and what's the target IP address, because that's how I define my rate limit.
Right.
So you can kind of do things to adjust for that dynamically, and we see some of that in industry, but it can't be done without the aid of machine learning, right? You need machines analyzing traffic to suggest what rate limits should look like, and we
Yeah.
do that right at Salt.
Right.
Um, but even still, right, that's it. It's a network-based control, right? You're going to kind of throttle somebody's connection down. So it might help with brute forcing or certain credential stuffing type of attacks, but like we said in previous sessions, attackers are sophisticated. They'll learn what your rate limits are, and they're going to throttle their connections down to the point that you really can't rely on rate limits. They're not going to work. So.
Yeah. Well, and so another big trend, moving away from sort of the edge of the application and protecting things at the at the entry point. Another big trend is on the left side of the house. Shift left with security. Right. There's
Yep.
a ton of activity from developers becoming smarter about security and building in best practices as they're developing APIs to scanning technologies. So maybe you can talk a little bit about those and
Yeah. Yeah.
where they
Absolutely.
work and
Yeah.
where they fall short.
Yeah. And I mean, it's so there's there's a lot of value in shifting security work earlier into the development lifecycle. Um, Traditional security, very siloed. We would do things kind of at the tail end of development, pre-production. Let's try to test everything, right? Hit with the blunt hammer. Try to find all the issues we can. Maybe 2 to 3 weeks to do that. Sometimes longer, right? Months, and it's like next thing you know, the development team's screaming. That was kind of the world of waterfall, right? It's gotten
Yeah.
worse with agile teams, and business needs to move faster. You can't be waiting that long couldn't wait that long to test functionality, right? And you could argue
Yeah.
functionality is even more important. Like, is the code doing what it's supposed to? Otherwise you have quality issues. Security is always kind of sometimes it's an afterthought, but it's always going to kind of be second, right? To is this thing doing what it should be doing? So the uh, that reality of like security kind of coming in at the tail end, disconnected. It didn't work, right? There was always issues. You would address it in the next monthly or quarterly release, ridden with bugs and vulnerabilities. But we found comfort in that, right? Maybe it's because it was just kind of the state of the world. It was kind
Yeah.
of pre-DevOps. But DevOps philosophies and practices, they in agile methodologies, they aim to break that down, right? You can't have those silos. You need to share subject matter expertise. So security should be working with development and infrastructure and operations, right? We've talked a lot about this. Like some things occur in code, some things occur in infrastructure, and security. You might be doing some other runtime controls. Everybody should be talking. And the reality in most organizations now, modern IT, time's valuable, right? There's just never enough of it. So we're constantly seeking ways to kind of automate, collaborate more seamlessly. So, a big focus of this kind of shifting security left, it's partially culture, right? Getting that knowledge earlier into the hands of application and development teams as they're building things, right? If they're thinking about security, maybe they can avoid some of those issues like exploitable, like cross-site scripting exploits, right? But build input filtering into the code. And we can define those things as security requirements and then audit those things and code check in and as the code is built, and then release the code. So there's almost always a heavy focus on kind of build time security, checking everything in your build pipelines. It's kind of moved right from that pre-prod, let's test everything in 2 to 3 weeks, to now we're going to run our barrage of security scans as part of the build pipeline, our CI/CD process. Everything needs to be automated, right? It's not somebody running a scanning tool manually, right? In the GUI, like we're going to script this and then we're going to get results and pass or fail that build based on the output of the scans. So that's a big part of shift left, and it's absolutely worth doing, right? Because we can knock out a lot of kind of code level issues, some of which we've talked about. But we've also talked about issues that exist external to code, right? Or business logic flaws that are very hard to test for just examining code statically, right? You have to look at this thing in runtime, you have to analyze its behaviors. So you also have to balance that with looking at kind of this production or runtime security. I used to call it externalized security, but there's a lot of things that exist external to code, right? So it's there's always this kind of prevalent thought in security that if the application isn't secure in the code, it's never going to be secure, right? And we know like reality is something much different, right? You might not even own the code. It might be your supplier. Good luck trying to get that fixed, right? You still have to do your business, so you have to find ways to mitigate that. And we know like business logic flaws might not be fixable in code. Like the API might be working exactly as designed, but somebody's going to abuse it in a way you didn't intend. So there's nothing to fix in code.
Yeah, I think that's super important, right? It comes down to business logic a lot of times, and that it's very difficult to predict what is exploitable and identify what's exploitable when it comes to logic. I mean, I always think of developers are looking for ways to create functionality, like you said, make sure that the API or the application is doing what it was intended to do, make sure it can do it, efficiently in a scalable manner. And attackers have a completely different perspective. They're looking for ways to manipulate the functionality to make it do things it wasn't intended to do. Mm-hmm. So it's like, how do you develop features and APIs quickly and efficiently as a developer, and shift to the mindset of an attacker who's going to look for all these corner cases of ways to, kind of tweak and break things.
If you go deep down enough on that rabbit hole, Chris, I mean, you see a lot of like QA teams, like they're in a lot of places they're gone, right? QA would have traditionally been responsible for like, all right, well, this is the functionality. I'm going to test the functionality, and maybe I have some more time, so I'll test some misuse cases. But for a lot of organizations, QA is fallen by the wayside, right? So unfortunately, that brings quality issues higher up, and then you're gonna fix those on the next sprint, right? So Agile kind of mitigates that to an extent. Like you're iterating that rapidly, and you can release a code fix very very quickly. But yeah, it's a difficult problem to address for sure.
Well, let's think about things as like a clean slate. If you had a magic wand and you could create a clean slate, and you were to, recommend or implement security in an organization, what are some of the key components? What would you recommend that things be there? I mean, you mentioned some things that aren't working 100%, but obviously we still need them. But what would that look like?
Yeah, and I mean, I actually got this question pretty frequently, right? Particularly organizations that are just starting in their application security or API security, if they were concerned specifically about APIs, which was trending upward. A lot of times it was they might have started thinking about a larger security program, like what we were talking about, design time and development time, and they heard about DevSecOps, build pipeline scanning. It's a lot of work, right? You're talking about multi-year efforts to try to, do an application security program soup to nuts. But almost always the recommendation was get good runtime security controls in place, right? And that definitely includes WAFs, right? Like for catching those very well-known types of exploits on your general web apps, you're going to have them. If you want to mediate access to APIs, you're going to use API gateways. But if you have a lot of APIs in your environment, and you absolutely will, right? If you're building modern apps and consuming, cloud-based services, you need something in place that's kind of scanning your environment continuously, kind of filtering out all that noise. There's going to be a lot, right? There's a lot of network traffic. Well, what is the API traffic? What apps, does it belong to? And it might belong to multiple apps. So like those traditional classifiers of, this is my infrastructure, this is my system, this is my app bucket, they just don't hold up, right? So you need something that's much more continuous, it's adaptive, it can kind of figure out context of how your APIs are working. But yeah, it's kind of, if you have limited budget, you could do open source WAFs, right? Like that's the reality. You can stand up a mod security WAF, and a lot of the commercial ones are built on that. Right. But this kind of adaptive learning system, like what we offer at Salt, that's not something that comes free, right? You have to be analyzing this traffic continuously. There is no WAF-like thing you can stand up your environment that's going to give that to you, because it's just not the nature of the beast, right? We've talked about this over the past few sessions, like how distributed apps are and how APIs connect, and how you need big data to kind of analyze all this, and then machine algorithms that can kind of decipher all of that, right? Because a person's never going to be able to do it. So yeah, I mean that's the shortest answer I can give, Chris. Like traditional security controls can work, identity access management, absolutely, but recognize that APIs are likely going to become a very big problem very quickly. Attackers are going to target them. Have a plan to kind of procure a solution on that front.
Well, I think the other thing is that inevitably you're going to ship software with bugs and vulnerabilities, right? You can't catch everything. So having something in place at runtime to protect you, I think is critical. But finding that balance, I mean, obviously we want to continuously get better and more secure on the development side and smarter about security. And I think, developers are doing a great job there, but it's finding that balance between protecting things at runtime, knowing that there will be vulnerabilities, and continuously improving on the left side of the house as well.
Yep, absolutely.
Well, Michael, another great session. I appreciate your insights, and look forward to having you on another one of these so we can dig in deeper into APIs and API-based applications and API security. Awesome. And until then, thank you very much. We hope that everyone enjoyed this session, and we look forward to seeing you on the next one.
Good stuff. Take care, everybody.